Hello friends. Okay, so we're talking about vectors and we're going to look at applications that have like magnitude discussed. So I've got two examples just to kind of help you wrap your head around these types of problems. Okay, so in this first one, a boat is being towed by two other boats, with the first boat having a force of 840 pounds and then the second having 925 pounds, and the angle between these forces is 26 degrees. Find the direction and magnitude of the equilibrant. Okay, what is that? Equilibrant. So this is a vector that counterbalances a resultant force. So if the resultant is some vector u, then the equilibrant is negative u. Okay, so let's of course you know what I'm going to say. Let's draw a little sketch of this. Okay, so I have a boat being pulled along by these other two boats. So this boat has the force of 840. This one has the force of 925. This is my boat. Now, what I want to do is I want to find the resultant. So the resultant is the combination of these two vectors. Okay, so I talked about this in my introduction video. The way that you want to work through this is you want to construct, you want to construct a parallelogram like so. And so the resultant, there we go. Okay, so here's that resultant force. So I'll call this U. So the equilibrant then is going to be literally negative u. And actually I should draw it so it's going literally just the opposite direction. So negative u. Okay, so really if we find the resultant, then we'll find the equilibrant. And so in my introduction video, I talked about how to find this resultant, like the actual number for it. So this degree here is what? This is 26 degrees. And so a property of parallelograms is that the supplement, so this angle here, this can be found by taking 180 minus 26 degrees. So this angle here is 154 degrees. So now I can like label everything with this. Let me just erase this. So this side here will be 925. This side here will be 840. This angle here will be 154 degrees. Okay, so I've got, then I can use the law of cosines to figure out this side here, ultimately. So this side u, that's what I want to figure out. So I'm going to have that be my u squared. So this is going to equal, so using the law of cosines, and if you have no idea what I'm talking about, I highly recommend that you go back to my other video where I introduced this idea. I have other videos on this, so I'm just using what I've already talked about. Okay, so I've got all of these, and then cosine of 154, and this doesn't look like a 4, it looks like a 0, so let me just change that to a 4. Okay, so there is everything I need now to figure out what this resultant is. So let's do it. So, okay, now I have that this magnitude of u squared. So I got this big number here. So now I just need to take the square root. So, okay, in taking the square root, I get 1,719.87. All right, so now that I know what the resultant force is, and now I need to start thinking about this equilibrant. So let's start with the easier question. What's the magnitude of the equilibrant? So if I have negative, the magnitude of negative u, what's that going to be? Okay, so this is magnitude. So think about like, so if you get confused about magnitude, just remember like other magnitudes that you know, like how pounds work or how like miles per hour work. you won't have negative pounds, right? You won't have negative miles per hour. So that wouldn't make sense. So the magnitude of the equilibrant will be the exact same as the resultant. So same number. Okay, now what about the direction? What does that mean? So what the direction is getting at is, so from, say, this vector here, so what is the direction of our equilibrant? And another way that you can think about that, we know what the magnitude is. So starting with this vector here, the best way to think about this is, what angle do you need from this vector so that the equilibrant is in the right spot? So visually, I think it's easy, right? So you just draw the vector in the opposite direction. But now we actually have to think about, but how do I find what this angle should actually be? All right, so now let's call this angle alpha. And now we gotta like think a little bit of, how do I actually get this angle? Well, I don't have a triangle here, so I can't, that's not gonna help. But what I do have here, this pink line and this blue line, these are all like just a straight line, right? So if I knew what, let me make this nice and clear. If I knew what this little part here, if I knew what that angle was, then I could take 180 minus this angle measure, and then I would know what alpha is. So that's what we want to do. And I can figure this out. So the thing to remember is this u coming through here, this does not bisect the angle. So we need to treat this. So let me clarify what I mean by this. I'll draw it in a blue triangle. So this blue triangle here, we need to use this triangle and the information that we know about this to figure out what is this angle here. And I can do that now using the law of sines. So let me clear some space. And so I know this length, right? So I wrote what the resultant, what the equilibrant was, but this is the same as the resultant. So maybe I could just write this is equal. These are the same. Okay, so I know this length here. I want to figure out this little angle here, so I can use the law of sines. So I'm going to have, let's see, 1719.87 divided by sine of 154 degrees. So what is that going to be equal to? That's going to be equal to 925 over sine of, let's call this angle here, this little tiny one, let's call it beta. So I'll call this sine of beta. Okay, so now I just go through and I figure this out. So let's see. This is going to be 925 times sine of 154 over 1719.8. Okay, so if I work through that, that equals 0.2358. I'll round up. So now I have to take inverse sine to get that my beta is equal to 13.637. So I'm just writing a few extra decimals just to help make sure you got this right. Okay, so that's this little angle here. So now to figure out what my alpha is, which is also going to give me the direction, I take 180 minus this 13.637 degrees. I probably should have written a degrees there, sorry. And so that equals 166.36 degrees. And so that's the direction. And okay, so yeah, that covers this one. Okay, so another problem here. So you'll see these are kind of a similar setup. So I've got two forces, 150 pounds and 275 pounds acting on a point. In this case, I'm told what the resultant force between them is, and then I'm asked to find the angle between the forces. So I think you know now how to interpret this information, Personally, I think you know enough to solve this problem. So if I were you, I would pause and give it a try and then hit play. All right, so these are acting on the same point. So we'll call this 150. I guess I should make this way longer. 275. And so the thing that I know about them in this case, let's see, it's kind of a terrible looking parallelogram. Let me try to make this a little better. Sometimes drawing on screen is really tough. Okay, so I know that this resultant is 350. And so now what I want to do is I want to find the angle between the forces. So once again, you just got to think about this for a little bit. So I'm trying to find, this is the angle that I want. So I'll call this angle alpha in this case. Okay, so thinking what I know about parallelograms, I know that if I try to, create a triangle, so let's say I try to make a triangle, so I'm trying to make it nice and blue for you guys to see, so see like this. If I try to use this triangle, I know I could find this angle here. I'll call this angle beta. And I at least know if I find, let's see, that's a terrible looking beta. Okay, beta. I know if I find this angle beta, then if I take 180 minus that, that will give me the angle here, right? So that's what I'm gonna do. Okay, so before I go any farther with this, I just wanna note that the situation that I have here is a side, or what we're trying to get to is like a side angle side type of information. So I want to figure out what this angle beta is. I do actually know this side of the triangle. What is it? This side would be, again, 275. So I can use the law of cosines here again. Just in this case, I'm going to be solving for beta. So let's see. So I'm going to have 350 squared equals 150 squared plus 275 squared minus 2 times 150 times 275 times cosine of beta. Boom. So my cosine of beta then, let's see, this will be 150 squared plus 275 squared minus 350 squared, all of that over 2 times 150 times 275. So if I calculate that, I get negative 0. Let's call that 295. And so then I need to take inverse cosine to get that my beta is equal to 107.18 degrees. So now I know beta, so now I want to remember, what I was trying to find was this angle here, alpha. So my alpha will be equal to 180 degrees minus 107.18 degrees, so that equals 72.82 degrees. And so that would be the angle now between the two forces. Okay, and so just one other thing to mention here. So this would be the angle between the two forces. You can also have the angle between a force and the resultant. So if I were to say what's the angle between this 150 pounds and the resultant, that would bring you to like this little green angle here, and that would be, then you'd have to think through everything again. So just wanted to make sure you kind of understood some of that terminology. And otherwise, that brings us to the end of this video, so I will catch you guys in another one.